Welcome everyone. This is our presentation for CSDS 395, Spring 2021. Our project is CasePlace. I'm Elias Suarez.
I'm Rishi Kumbal.
I'm Cameron Farmer.
I'm Randall John.
I'm Michael Jutkovich.
And I'm Michael Cunningham.
We'll give you a quick intro. CasePlace is a progressive web application that aims to introduce and guide members of the CWR community around campus using Google Maps API to display information about locations that are related to campus, as well as other locations that a student might need or community member may need in their everyday life at Case. It provides a guide for specifically students and prospective students on where they might need to get around campus by highlighting important information, having different icons for the different types of buildings that are on campus, as well as the variety of services that are available to them. So the problem that CasePlace addresses is the fragmentation of CWRU's campus. Because of the oblong shape of our campus, you can't really just walk from one end to the other and find everything that you need in between. And this is especially difficult when you're trying to give instructions or directions to someone who is not familiar with campus, because without a point of reference, it becomes very quickly, you realize how difficult it is to say, oh, head this way without any point of reference. And it can't just be, straight left or right, because our campus is just shaped like a block. And many students, given the COVID-19 pandemic, haven't even gotten the opportunity to be on campus or necessarily visit the buildings on campus that they would have otherwise. And this issue arises especially for our incoming students who might be coming to campus for their first time and still need to get familiar, but don't have an easy grasp on how to do so. So because most students are familiar with Google Maps, we decided to build on top of it so that the user behavior is similar and people are already familiar with it. And by making context-specific locations and filters, then that adds the most relevant information for the user.
Just a quick overview of the features that we implemented. So when you open the application, the user will be greeted with a prompt to select their type of user, whether that be student, prospective student, or a guest. And then based on that, there will be a variety of locations displayed, which the user can obtain information. And these locations are essentially filtered based on that user's like how much information we thought they would need, which is what we'll talk about on the next slide. And then they'll be able to access directions from one location to another, as well as information on a variety of locations. And then they can further filter among the locations based on food or other categories. And then on the next slide, we'll talk about a little bit more about this. So as you can see, this is kind of our overview of what each user would need to see. So you can see for prospies and parents, they'll just have a general overview of campus. And then as you go into current student, it'll be a little more specific with study areas and other departments and services that are available to students. And that's just not to smother prospective students with so many locations. And then for the guests, it'll be similar to the prospective and parents, and also with the entertainment added to it.
All right, and now we'll go over the development process.
So the technology we use for this application, firstly for our development and our actual coding of the application, we use React.js, which is a React library or a JavaScript library that we'll talk about later. And we use that for device agnostic app development. In order to provide the mapping functionality and the data and methods to actually implement that, we integrated the Google Maps API into our application. To enable code sharing and collaboration between team members, we used GitHub. And we also integrated GitHub with the DigitalOcean app feature in order to create a build pipeline for our application. This allowed us to push our code to the main branch and immediately trigger a build to a live environment for our application. This allowed us to be very agile and allowed us to catch bugs in real time. Finally, we also use Figma for the design process. We use Figma to design all of our assets, all of our user journeys. And this made the development process a lot more seamless, as we already had an idea of what we wanted each individual page to look like. And we also had the styling elements for each of the assets that we would come to use in our application. Finally, to increase our agility for this application and the development process, we used Atlassian Jira for project management. Jira allowed us to create cards that we could assign to each team member. This allowed us to see who was working on what task, so we weren't stepping on each other's toes. And it also allowed us to actually define the tasks that needed to be performed at any given stage in the development process.
All right, so why is the software design phase so important in software engineering? Well, the first reason is modularity is of great convenience. Modularity is basically the cleaving of your huge software project into smaller modules. It simply means splitting the software project into small pieces or small tasks, called modules, for the simplicity of work. It turns out that splitting your software project into modules not only makes it easier to work, well, yeah, it makes it a lot easier to work on every requirement of the project. It also gives the convenience of making changes in the future. For example, if the requirements of your client changes, then you can always opt to restructure a module and not the whole project. This delivers to you the ease of finding errors in the modules and not the whole structured, complicated code that you have. Also, as software design is performed by creating modules, it makes the software easier to maintain. Tasks like finding bugs, debugging those bugs, restructuring, and changing the functionality of specific elements in the software app can become quite easy due to good software design. A good software design also gives you the privilege of changing the appearance, functionality, etc. of the software by working on a specific module. For example, say you've already completed the creation of a software app, but you need to change its interface. With the sound software design, you can simply make changes in the module that relates to the interface, and you don't need to mess with any other module, and this makes it very easy to maintain. Furthermore, software design is a reflection of the performance of the software application. A good software design effectively displays the flow of functions taking place while the software is running. From input to output, a good software design shows all the steps so the performance of the software application can be analyzed easily. For example, if a software project is passed from one software engineer to another, the engineer on the receiving end should be able to understand the software just by reading the software design. Now, when it comes to making changes in the software, aspects like portability come in handy. A lot of portability in the software design gives the convenience of transferring functions from one module to another, and it can make a big difference in terms of the functionality of the software app. Another important element of software design is trackability. Trackability is, as its name suggests, the level of aptitude for tracking the flow of functions taking place in the software. Good software design trackability um, Good software design provides trackability to the software application, which makes it easier to use and maintain. So in terms of our project, we made sure to take a few weeks before diving in and coding to develop a sound software design for the project. As Rashik mentioned earlier, Figma was used to create low-resolution wireframes, and then we used these low-resolution wireframes to develop higher resolution wireframes that we would use for the base of coding off of. We also drafted extensive user journeys to cover all of the different scenarios our user could encounter. So these are some examples of mobile high-resolution wireframes. As you can see, the user experience starts with role selection, and then the user chooses search parameters that they're looking to narrow their search. And then on the next wireframes, it's showing the map with markers coming up. So in our actual implementation, you can see it's similar to the wireframes. We have our whole role selection again, and then search parameters, and then the map comes up with markers and tooltips, as well as radio buttons on the top to narrow or widen your search. This is an example of a high resolution desktop wireframe. You can see On the left side, we have accordion cards that we want to expand and show location information. And we also have the map on the right side with the markers and the radio buttons. So in our actual implementation, we have the whole choosing a role at the beginning, and then the map will pop up with markers and the accordion cards on the left, and the radio buttons on the top. We have our tooltips with information regarding the locations. And finally, we have the expanding accordion cards, which you can click on to see more information about the location.
So for our actual implementation for this project, we coded in React.js. And React.js is a JavaScript library that we used to ease the development process. And it eases the development process by taking a traditional JavaScript, HTML, and CSS application and dividing it up into modules. These modules are important. So these modules in React are called components, and we use functional components for this application. And to create this application, we use the Create React application template provided by Facebook. So the Create React application template bundles the Babel compiler, which is a JavaScript compiler that's an alternative to the traditional one. It bundles all the packages that we need and all the other NPM dependencies that we need as well. And we used all of that to build our application. Additionally, we used SCSS as a styling framework. SCSS is a superset of traditional CSS that adds increased support for variables, it adds increased support for object orientation, and it makes the development process much easier. So React itself makes the development process easier by creating these components. And these components allow us to use these things called React lifecycle hooks. And we used React lifecycle hooks heavily throughout this application. In fact, we used the useState hook to define our state and our data layer for the entire application. And in combination, this made for a very good device agnostic development experience because React is a web framework. That means we can use it on both an Android device, an iOS device. We can use it on desktop. We can use it in a car if we wanted to. Anything that has an internet connection, we can use React.js to build an application for.
And so as we began to enter the backend or the ending phase of our development process, it became time for us to start doing quality assurance as well as testing to make sure that our application was measuring up to our expectations that we had laid out at the beginning with our design process. So it was very important to us that our application was device agnostic. So we were able to have it work on both phones and desktops, as Rashik said, so anywhere with an internet connection. And so what this meant is that we needed to ensure that there was equivalent performance in all platforms, as well as easy to use on all platforms. And this led to some problems later on that we didn't foresee at the beginning, which I'll be getting into later. Those problems mostly pertain to the interface being different for each platform. And as a result, it was either more cluttered or it didn't really make sense to have certain things laid out in different ways. And so that was a problem that we had to overcome and kind of adapt on the fly as we were ending our development process and wanted to make sure that we had the highest quality application available. It was super important to us as well that we had an intuitive interface because our target audience is people who are not familiar with the CWRU community and are looking to learn more information. So we needed it to be as easily accessible and easy to navigate for anyone. And this meant that we wanted our UI to be as clean and simple as possible without lots of cluttering or lots of overwhelming information that wouldn't really be helpful when assisting when the goal of this application is to assist people in like finding new things out, not the expectation that they already know what they're looking for. So here I want to now talk about one of the distinctions we found, and one of the changes we had to make on the fly as we decided that the application as it looked on mobile wasn't quite up to our standards. So here we have on desktop, we have the accordion cards on the side, and then we also have tooltips when you click on an icon or to get more information about a location. But on the next slide, if we look at how it looks on on mobile, we can see that we decided to remove the accordion cards and rely solely on the tooltips to provide this information. This is because we found that when first using our application on mobile, the accordion cards kind of took up half the screen, and it made it a lot harder for people to use it. And it was very clunky, it was over-cluttered, and it was not very simple. So as a result, we decided that on mobile, it would be best for the user if we didn't have the accordion cards, and instead they would have this contextualized map where they can select an icon, and then from that icon, they can then click a link to go to Google Maps. And then they'll open up Google Maps and they can get directions to that place. And this way, it's super simple for anyone to pick their role, what they're looking for, and then search through these locations, find ones they want to go to, and get directions. So we obviously had a lot of goals that we set out at the beginning of this project, and I think we're all very proud of what we've accomplished. And we managed to we've managed to accomplish the entire scope of our project. What we have now is what we set out to make, and we're very, very pleased with how it looks. However, since a lot of us were learning about React.js over the course of this project, we learned a lot of the capabilities that React.js has that we actually, if we had known about earlier, we would have been able to take advantage of. So this includes, like, we could have made some improvements to our project if we were perhaps more experienced React programmers. But regardless, these are things that are outside of scope. And so perhaps these are things that we'll come back to later. Some stuff that we thought of as we were kind of reaching the ending phase of our development process was perhaps adding bus routes. So when you click on like a location, it can show you the routes of the buses, not just the stops. Perhaps having in-app GPS navigation, so there isn't the like disjointment of like clicking a Google Maps link and then opening a separate app. Perhaps we could merge the two and have it work inside of just one app. We're also talking about perhaps having a legend for map icons for the clarity of users, for clarity of information for users so they know what they're looking at. And we messed around with this idea a little bit, but we weren't able to find a good way to make it visually appealing while also staying true to our goal of not cluttering our UI. Furthermore, we would perhaps want to think about using a live data layer, perhaps incorporating a database. And in doing so, we'd be pulling information from web pages, like off the internet, perhaps through the Google Maps API, as opposed to having all of these locations saved saved in a JSON file for locations. And all of this would kind of work towards having a more reactive map, where we would have this information that is in a live data layer, which can perhaps be updated with like user reviews or open hours and closing hours. But we could also have the map maybe change and center based on what someone's looking at. So if they select something in the list on the accordion card, it zooms in on that part of the map, kind of making it more dynamic for the user and easier for them to get directions. And furthermore, we could also maybe talk about changing our icons and making them more modular. So maybe they're shrinking or they'd like vanish at certain times, depending on what people are searching for. And all of these things are possible within React, and due to its flexibility as a framework, and are things that we perhaps starting to toy around with as we reach the end of our project.
Thank you for listening, and we'll now move on to a live demo of our website.
This is our application, CasePlace, built and deployed using DigitalOcean. We decided to use DigitalOcean's cloud platform to build and host our website because it had the ease of access was great and the integration to GitHub. Whenever we made changes and pushed them to our main branch in GitHub, it would automatically update our deployment so we could see the changes we made reflected on an actual production environment. This allowed us to debug as we went along the development process and adjust things as we saw fit because we were able to see what state our project was in once we made some major changes and pushed it to our GitHub. So I'll be walking us through the parent or prospective student user today. And you can see from this welcome modal that we have 3 different roles for the CasePlace users. You have current student, guest, parent, or prospective student. We really developed the app with the parent or prospective student first and foremost sort of in our mind, because that is the group of students or users that are least familiar with campus and would need the most type of direction, as well as they would be most curious about the variety of locations on campus. So once you click here, you can see that there's 3 different categories they can choose from: campus buildings, food, or transportation options. And because the parent or prospective user is only on campus for generally 2 to 3 days, you can see that these 3 categories are the most relevant and the most context specific for that user. So instead of giving them a long list of every single place that's affiliated with CWRU, we decided to break it down into smaller categories that would be most relevant for that type of user. So you can see if we go back and click on current student, there's a variety of different services and locations available to a current student, but that's because the current student has different needs than a parent or a prospective student. So if we continue here and click on campus buildings, you can see that we have a variety of icons overlaid on this Google map. And these icons help the user visually make a distinction between the types of locations on campus. So you can see the academic hats here. Each color represents a different school. So the green is for College of Arts and Sciences, the blue is for PBL, the business school, and red is for College of Engineering. The houses are for university housing that's related to CWRU. The bandages are for health and medical services, and the pins are general locations that didn't fit into a neat category, but are still CWRU affiliated and relevant to these users. And the barbell are for locations that are health and wellness related, such as gyms. So you can see on the left over here, we have these accordion cards. And the accordion cards are so that the user can also scroll through the list of all of the locations and they can get some information about it. So if I want to go to One-to-One Fitness, I click here and it shows me information about that place. The purpose of these accordion cards was really just so that the user, if they're on desktop, can, instead of just clicking on the map, they can also get a feel for all of these places if they just wanted a long list directory. If we go to the food tab, and well, one of the big features is also this navigation tab up top. As you'll see, that it's the same 3 categories that were available to the user when they first chose the parent or prospective student role. So if we click here on food, you can see the locations are kind of sparse, but that's on purpose. When you're a user who's only going to be on campus for 2 to 3 days, we wanted to highlight the places that are most specific and most relevant to you. So considering if you're staying on campus and you might not want to drive or go too far to get food, we highlight all the places that are near campus uptown for you to get food. And you'll see here that clicking on these locations will give you a tooltip with some information about the food location. And this same tooltip capability is available for the directory as well. But it's nice to highlight here because if you're looking for food and you're not completely sure about what type of food you'll be getting from the name, then you can look and see some information about that place. So now we can go to the transportation tab, and this highlights all of the commuter links that are nearby. One of the feature improvements that Cameron mentioned was showing the actual route for each location, which would be nice because if you click here, it'll tell you which link it's on. So we have the distinction between green link, blue link, and red link. But they all are disparate. So for a feature improvement, it would be nice to show the complete route with the icons. But as you can see here, we still highlight a wide variety of the stops, at least that we see as being most context specific for the parent or prospective student. So if we go back to the directory, we can see here all of the cases, all the places that are related to case, and it also not only being visually distinctive using the icons, it gives the user a better understanding of the lay of the land of CWRU. As you can see, it encompasses a very large space from all the way to South Residential Village housing over here to the North residential housing over here. And by giving this information on a Google map like this with visually distinctive icons, a prospective student is also able to answer some of their questions. So if they're planning on studying a major in engineering and they know as a freshman they live in North residential housing, they can see that it's going to be a bit of a walk from housing to class every morning. If they're studying in the College of Arts and Sciences, not too bad. As you can see, all of the buildings are up here. Or if they're studying business, PBL is right there. They also can get a feel for, well, if they're studying engineering second year, they can see that all the university housing for second year is here and that it won't be too bad of a walk. The importance of these icons is really being able to give the user an understanding of where things are in relation to one another. And I think we've done a good job to achieve that. And the most important thing with this application was that it provided useful information to its users. And I think that our team did a great job in making the icons distinctive and locations important enough that if a user were to open the app, they could find their way pretty quickly. And to ensure that, we made sure that when you click and you see in Google Maps, you can click on the link and that will take the user to Google Maps. And from there, they'll be able to enter directions from their current location, get even more information about it. And this way, we didn't have to port all of this information manually over to our app. So we click on the back button, it'll take us back. And that is CasePlace. Thank you so much for watching our presentation. I hope you enjoyed.